Number 19. Volunteers are needed to do a total of 60 hours of work at a concert. The shortest volunteer shift is 2 hours and the longest is 3 hours. So that's telling me that everybody works between 2 and 3 hours. Which inequality shows V, the number of volunteers needed? Well, we know that we need between 20 and 30 because that's the only set of answer choices we could have. 20, 30, that's all I have to choose from. Now, this one's a brain bender to me. I'm going to show you a way to eliminate some answers, and then I'll show you how to work it. But this is a tricky one to me. I can eliminate A for this reason. With this type of problem, your arrows must go the same direction. You can't have greater than and less than in the same answer. So I can eliminate A. It won't work to have them going opposite directions. The same is going to be true for C. You have this one saying less than and this is saying greater than. That won't work. So we can take that one out. Unfortunately, I can only eliminate 2 of them. Now, if you wanted to take a guess, that would be fine. You could eliminate 2 answers and work it down to guessing 1 out of 3. But here's the solution. Let's say that everybody, all of the volunteers we had, worked 2 hours. Even though they could have worked 3, everybody decided to work 2 hours. So let's apply that to our formula. That would mean that everybody's working 2 hours. So every volunteer that worked 2 hours, and that was a total of 60 hours. Okay, so if you solve this, actually, I'm going to do it as an equal. Let me think a minute. Do I want to do it as an equal? No, I don't. I'm sorry. I was right to start with. 2 hours per volunteer is at most 60 hours. It is exactly 60 hours. I was thinking of backing off and doing it with equal, but I'm not going to do that. So let's solve the inequality by dividing it by 2. So that means that at most you would need 30 volunteers. Okay. So let's say that everybody worked 3 hours. So what's that going to do to the total number of volunteers? If they're working longer shifts, I won't need as many. So if we have everybody doing 3 hours and we have to get to 60, that means that every volunteer would work at most, every volunteer is working 3 hours, so at most I would need 20 different people. And there are the numbers we're looking for. This is the 30, and this is the 20. The question is, how do we put those together using the right arrows? The arrows are already going the way you want them to. The answer is going to be E. Because what this is saying, we don't know what everybody's going to work. They can choose a 2 or a 3. That's why there's uncertainty here. That's why the equal would not work, because I don't know exactly what people are going to choose. But I know that if everybody chooses 2 hours, I'll need up to 30 people. If everybody chooses 3 hours, I would only need 20 people. So the actual number of volunteers could fall anywhere in that range. They could all choose 2 hours. They could all choose 3 hours. There's uncertainty here, but I know that it would be in that range. Because even if everybody chose 3 hours or 2 hours, we're still, to get to that 60, it would be in this range. I don't think I've explained that very well. This is a hard one for me to explain. I know in my head what it should be, but explaining it to you is difficult for me on this one. I can tell you to eliminate A and C because the arrows are going two different directions, and you don't want that. You want them all pointing the same way.